All right, so let's go ahead and jump in here and start exploring these Numpy array attributes. So again, just sort of going over it, we have the end dimension, we have the shape, we have the size, we have the data type, and we can sort of mess around with those a little bit. Okay, so obviously, before we do anything, we need an array to play with. So let's see if we can't make an array. Actually, let's make a two-dimensional array. We're going to use np.random, and we're going to create random integers. Okay, we want to get a range from 0 to 10. Let's go 0 to 20. Okay, so a range from 0 to 20. Now we need to give it a size, and we're going to do a two-dimensional array. So we're going to create a tuple. We're going to get 3 rows and 4 columns. Okay, so just to validate that that works, we're going to go ahead and print R2 right here and run it. All right, so there we go. We've got our values there, 213, blah, 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 blah. It goes up to 19 because 20 is non-inclusive. All right, so very good. So now let's go ahead and explore some of these properties, okay? So I can just go ndim, okay? So that should give me the dimensionality, okay? So it has 2 dimensions, which is correct because we created a 2-dimensional array, okay? Now I should be able to look at the shape of it, which should tell us what, how big the dimensions are. Okay, so it's 3 rows, 4 columns. Very, very good. Now we should be able to use the size to see how many elements we have total, which is 12. Okay, and a way to know what your size is generally is just the dimensions times each other, right? So 3 times 4 is 12. Okay, 4 at 12. If I added 5 there, they'd be 12 times 5. So 3 times 4 times 5 would give you the amount of all of the different elements inside of that particular array. Okay, so we can also look at the D type. Okay, so D type stands for data type. We know that we created an integer, so it should say int64, and it does, okay, because the default data type in Python is a 64-bit integer. Okay, so we can sort of explore those things, look at them a little bit, okay, and mess around with that. Now, let's imagine we want to go ahead and mess around with our indexing. Okay, now keep in mind, as we're doing this, every time I hit run, it's generating a new random array, okay? So if I come down here and I want to get this 8, I can't because when I run it again, the array looks totally different, okay? When I run it again, it looks totally different, okay? So what we're going to do is we're just going to sort of experiment getting certain things out of here, okay? So let's say we want to get just this row, okay? It's really easy because I can just go, hey, get the 0th element out of R2. Okay, so that'll just get the first row. Okay, I can also get the second row right here. Okay, so that'll get the second row, and I can also get the third row, right here. Okay, now obviously if I try to go up too high in terms of my indexing, it'll cause an issue, right? An index error, because the size is not big enough to go up to 0, 1, 2, and 3, because that would mean I would need 4 rows as opposed to 3. Okay, so let's go ahead and get the 1th row, or I would say the 2nd row, and let's get the 2nd element, which would be the 1th element. Okay, so we can actually deref that, and actually we can do it sort of vanilla Python like this. We can also do it very NumPy, which is very mathematical, so it'd be 1, 1. Which also gets us the number. Okay, so that's how we sort of index. Now we can also do the negative stuff. So if I want to wrap it around, I can also do a -1 to get the value off of the outside of that. Okay, so to prove it, let's go ahead and print R2 so that we can actually see that we're getting what we think we're getting. Okay, so this one printed 11. So we're going to 1, so 0, 1, so it's this row. We're getting the size, which is 1, 2, 3, 4, minus 1, which is 3, 0, 1, 2, 3, we're getting 11. Okay, so that's sort of the way that that works. All right, so that's how you index in 2 dimensions. 1 dimension is very, very easy because you just, use a single index just like a list. 3 dimension gets a little bit harder because you have to get the dimension, and then you have to get the row, and then you have to get the column, and it gets a little bit more complicated. We're going to move on from that now just because it's a little bit more advanced. We'll talk about multidimensionality in future classes. Okay. Now I want to keep your minds focused on this idea that every single array has a single data type. Okay. So we created an integer here, right? So I could try to change the value in R2 at some index, say 1, 1, to something that is not an integer. But as I explained earlier in the videos, it's going to have to convert it to an integer. So just for fun, let's do a 3.9. Now, this is a common mistake that a lot of students make. They think, okay, if we're going to turn that into an integer, we're going to round it, and 3.9 rounds to 4. And actually, let's make that a big number so we can tell the difference. 111.9, okay? You would think that that would round to 112, but in this case, it simply truncates, which it just highlights the 0.9 and deletes it, okay? So you're going to see 111 added into the array. And actually, I need to print that so that we can actually see it happen. There we go. All right, so we saw previously that we had the 1th element, the last one, which is 8, and we converted that to 111, and it did not round it. Okay, so understand when you're moving different data types into arrays, it's actually going to truncate it. It's not going to round, so don't make that assumption. If you want to round, there is a function in Python called round. Okay, so now let's sort of mess around with this idea of creating sub-arrays. All right, so we have array number 2. Let's imagine trying to grab some subset of array 2, ARR2. Okay, so we remember that we have these colons, right? Okay, here would be start, here would be stop, here would be step, start, stop, step. Okay, so if we want to start at the 2nd element, okay, and we want to stop at the 3rd, and we want to do a step of 2, this would be the outcome, okay? We would end up with 16, 14, 13, 11, okay? 16, 14, 13, 11 would be this bad boy right here, okay? Okay, because it's basically saying 2 to 3, 0, 1, 2, okay? So the only 2, 3 is non-inclusive, and actually that was dangerous because I could have got an exception. So let's actually go 1 to 2, okay? Then we get 2, 19, 2, 18, okay, because we go from 1 to 2, so it's only 1, so 0, 1. Very good. We step by 2s, and there's really no way to step around that, okay? So that's essentially what you're doing with your start, your stop, and everything that you're doing there, okay? We essentially got our 2, 19, 2, 18, and made our subarray. I would encourage you to explore that a lot more, mess around with that, especially if you like making subsets or doing any sort of research or interest in research where you might have to make a lot of different subsets. Okay, now just to experiment with this, we can also do this idea of reversing, just to show you what that looks like. Okay, so I can just reverse this, and essentially I get just the back, I just turns it backwards, right? 113, 9, 11, 8, 2, 8, 19, 14, 16, 1, 3. That's kind of what we got. It just flipped it around. Okay, so it created a mirror. In terms of what that is. Now, if I want to do that individually in a multi-dimensional situation, I can actually just do a comma on both, right? So now I'm saying for the first set of lists, we're going to reverse it, and then we're going to also reverse the others. Okay, so now you can see how 14, 16, 113 is still in the right order. In this case, it's also going to reverse that. So we should see pretty much a direct mirror, okay? So 6 is now 6, 8 is now 8, 4 is now 4, 4. See how that kind of correlates. How this was reversed to this was reversed to this, and so on and so forth. Okay, so that's how you can kind of reverse the arrays that you have, okay? And again, if we want to just sort of get different columns and rows out of these, so to get a row is very, very easy. You just give it a number, right? Okay, so this is going to give me the 0th row, 11, 16, 5, 19. There we go. If I go 1, it's going to give me the index 1 row. Okay, 0, 18, 12, 10. If I go 2, it's going to give me the last row in the array. Okay, 14, 6, 0, 13. Okay, so now let's imagine we actually want to get the column, okay? And we talked about this a little bit earlier, and this would be the way that we do it. So let's say we want to get the 1 column, okay? So it'd be like 0, 1, so 7, 1, 6 in this case. We can use this sort of a format, okay, where we say, hey, start here, start at 0, go to the full distance on all the rows, and just give me 1, okay? So that should give me 14, 15, 4, 14, 15, 4, okay? That is column 1. Okay, if I want column number 2, I can do the same thing. Okay, 10, 12, 6, 10, 12, 6. Okay, so it sort of allows you to grab a column, turn it into a subset so that you can do some sort of numerical calculations on that. Okay. All right, I believe that's about as far as we're going to go on this section. We're going to move into some universal functions next. and actually getting into some of the powerful computations. And then that should round out this module. We'll see you shortly.